Hello, my name is Scott McMahon, and today I'm going to teach you about how to use pandas for data manipulation with Python. Pandas is a very useful library for using data in Python. And of course, to use it, you have to import it. So import pandas as PD. PD helps to shortens it instead of writing out pandas every time. Next thing that you need to do is read in the data from a CSV file. And you can get the file that I'm using from my GitHub page, and I'll link to it at the end. Let's say data frame equals pd.read CSV. Read CSV is the command that you use. And in this case, it's kc underscore house underscore data dot CSV. And I've already uploaded it to Jupyter Notebooks and already started a project called Pandas. So, so DF stands for data frame. PD is pandas read.csv, and then the file name. It automatically looks in the same directory that you save your projects in. I already uploaded it in Jupyter Notebooks, so it's already there, so it knows where to look. And now you print the data frame, but you don't want to print all of it. You only want to print a little bit of it so you get an idea. df.head. Let's do the first 5 rows and see what happens. Okay, a lot of columns here, don't know how many. Lots of, look, okay, they are all numerical. Good to know. ID, date, price, bedrooms, bathrooms, square foot living, square foot lot, floors, waterfront, view, grade, square foot above, square foot basement, okay, etc., etc., etc. Okay, they're all numerical. Well, looks like they're all numerical. Let's find out a little bit more about this. Instead of doing head, let's do shape. How big is this? Okay, it's pretty big. 21,613 rows and 21 columns. Okay. Now, one of the things that you can do in Jupyter Notebooks is to if you put a question mark after a function, shape, for example, it will tell you all about that function. Oh, actually, it's a property. Okay, it says type property, string form, property object at whatever, docstring, return a tuple representing the dimensionality of the data frame. See also in the array shape. Okay. And then it gives some examples. Okay. That's very useful to know when you're using Jupyter notebooks, that you can just put in a question mark after an object and it'll tell you about that method or property. Or okay. Now, it's also important to print out or to find the names of the columns. Okay. It said that there were 21. Okay, yeah, there's a lot there. ID, date, price, bedrooms, bathrooms, square foot living, square foot lot, floors, waterfront view, condition, grade, square foot above, square foot basement, year built, year renovated, zip code, latitude, longitude, square foot living, square foot lot. And okay. Then let's do one more thing. Find out the data types of the columns. Okay, now it prints out the names of the columns and their data types. Okay, ID is an 64-bit integer. Date. Okay, that's interesting. It's an object. Okay, that will be useful to know. Okay, price, floating point, integer, that means, or floating point, that's integer with decimal places. Okay, yeah. The only thing that's unique is the date object. Okay. Another thing to do to find out about the data is to do describe, the describe function. And because it is actually a function and not a property, you put parentheses after it, and then you also put another close parentheses because the print is also a function. Okay. Now, the describe function does a count of the number of items in the entire data frame along each of the columns. Then it does the mean, the standard deviation, the minimum, the maximum, 25 percentile, 50 percentile, 75 percentile. And some of those numbers have meaning and some of them do not. If it is above okay. If it's above 9,999, does it in scientific notation. We're not going to mess with formatting in this tutorial. We'll worry about that later, but the number is still there. Okay. And let's look at the mean and see which ones have meaning. The ID, the standard or the average doesn't really mean anything. The price, the average price, okay, that means something. The average number of bedrooms, that means something, but you can't have a decimal place number of bedrooms, not really. Bathrooms, okay, this is a little unusual, but you can have a quarter of a bathroom or a half of a bathroom or 75% of a bathroom. Ask your realtor about that. I'm not going to get into it, but the average of that, it has some meaning, but it's a little strange. Okay, the number of floors. Okay, waterfront. That's an interesting one. It's either a 0 or a 1. That's a categorical or Boolean variable. So the average of that doesn't have meaning at all. Okay. Now the number of views, it can have 1 to 4 views. Oh, actually it can have 0 to 4 views. Excuse me, but the average of that, again, doesn't have meaning. Anyway, you can get the idea of which ones have meaning and which ones do not, because you realize that the variables are continuous or they are discrete integers. Okay. Now let's take a look at ways of selecting data. Best way is to do set of variable equal to the data frame and iLoke. And you do square brackets. In this case, do 16 comma 5 and print df2. Okay, iLoke stands for iLocation, index location, and 16 comma 5 actually does the 17th row and the 6th column, because indexes start at 0. Okay, it returns a number, and the number's nice, but because you don't really know what the name of the column is, iLoke by itself may be a bit tricky to use, and you might be safer to use another function or another property called Loke. But let's try iLoke with something else just to see. Let's do all of the rows in the 5th column, whatever the 5th column is. Okay. Okay. It seems that the 5th column is SquareFootLiving. Okay. Okay. Tells you that at the end, which is okay, and it does that for every single one, but it cuts it off after 30 and then jumps to 21,583. Okay. So it doesn't print out all of them. There is a way to print out all of them, but we're not going to get into that today. This is just a basic tutorial. So iLoke looks at the index, and the index, both the row index and the column index, start at 0. So we have to keep that in mind. Okay. Next thing to look at, and this is perhaps, I think, more useful, is the Loke function. The Loke function stands for locate, and you set that equal to the data frame and the column name in single quotes. Okay, we'll have to go back and look at that, reprint that out just to get an idea. Columns. Okay. Comment that out and comment that out. Okay. Okay. So those are the column names again. So you get an idea. And let's do SquareFootLiving because that's the one that we did before. And all the column names you'll notice are all lowercase, and that's nice and easy to remember. If they were uppercase and lowercase, Python is case sensitive, and that's something you need to note. Okay, so SquareFoot underscore living. And then outside of the square brackets, let's make it equal or greater than 2500. So it will print out all of the houses with a square foot living space of greater than 2500. See how many there are. Okay, apparently quite a few. Yeah, there are 5,697 of those that meet that criteria. Okay, Loke is a very powerful function, and there are ways of doing multiple conditions in a Loke statement and to select things. We're not going to get into that, but there are also things that you can do where you have it equal to a particular amount, exactly equal. And when you do a comparison in Python, comparing values, the square foot living column, and you compare it to 2500, you do a double equal sign. So this finds all the ones that are exactly equal to 2500. Okay. 90. A lot fewer are exactly equal to 2500. Okay. Now I'll find the ones that are less than or equal to 2500. So this would be 90 plus all the ones that are less than 2500. Wow. Okay. That's most of them. 15,916. Now let's make something that's a little bit unusual. Let's make it greater than 5,000. That's a big house, and there aren't going to be that many that are bigger than that. Let's see how many. Okay, 211. It's more than I thought. Okay, one thing that you will notice is that the date has all the T and then all these zeros after it. It's actually a date time object. And all the zeros after it don't tell you anything. And there's a way to change it from a date time object to just a date object. And I will show you that here now, but again, you don't need to know how that works. I'll just show you it. you can assign a value to a column. And again, when you assign a value and not compare it, you do single equal sign. Don't need to know how this works, just need to know that it does, but date, in this case, is just the name of the column. Okay. Now, then you print okay. This is actually exchanging the date time object for a date object. And it doesn't change the CSV file. It just does it in the memory. And you want to realize this, but after this, every time it does the searches for the date object, it will find that. Instead of date time, it will find date. Okay. Whoops. Oh. Okay. Well, that didn't work. I had it down, but I guess I did it wrong. We'll figure that out later. Okay. There's another command that's very useful in Pandas, and that is sort values. df period sort underscore values. Then the couple of the column names. Let's do SquareFootLiving and price. And let's do that, both of them descending. So we put ascending equals false. F-A-L-S-E, capital F. Otherwise, it doesn't recognize it. And then print df2. Okay. Now it prints out the entire data frame and sort values. That's a very useful function. We can do, what if you want ascending the SquareFootLiving to be ascending and the price to be descending. So that would be 1, 0. Try that. Okay. Okay, square foot living and price. Okay. That concludes this basic tutorial about using pandas and manipulating data, and mostly just looking at the data. Like my Facebook page uh, and my YouTube video page or channel, and go to datascienceexamples.com to find out more about this. Thanks.